we will produce the graph of rational functions using limits. This is what we spoke about last time. Given a rational function, where the degree of the function in the numerator is n, and the degree of the polynomial function in the denominator is m. If n is equal to m, this is the horizontal asymptote. This is just the numerical coefficient of the leading term in the numerator divided by the coefficient of the leading term in the denominator. If n is less than m, the horizontal asymptote is the horizontal axis. If n is greater than m, the function has no horizontal asymptote. But when n is 1 greater than m, what you have here is an oblique asymptote. This is our guide to sketching the graph of rational functions. So when we are given a rational function defined by y is equal to f of x divided by g of x, the first thing that we must look for is the x-intercept. And we can get the x-intercept by looking for the zeros of your function in the numerator. Where or when is that equal to 0? After that, we look for the vertical asymptotes. And we can do that by solving this equation. Where or when is g of x equal to 0? We will look for the horizontal asymptote by looking for the limit of our rational function. But because we already have the theorem, we don't have to always evaluate the limit of the rational function as x approaches infinity. We can just use our theorems. So for example, I have a function or a curve that is defined by this. Y is equal to x minus 1 divided by x plus 1. So where or when is this equal to 0? Well, obviously, it's equal to 0 when x minus 1 is equal to 0, which means when x is equal to 1. So this is the x-intercept. Next, the vertical asymptote. Where and when is our function undefined? So it is undefined when x plus 1 is equal to 0. And that is true when x is equal to negative 1. So that is the equation of our vertical asymptote. And then we shall look for the horizontal asymptote. We don't have to evaluate the limit of this function as x approaches infinity. We can just use our theorem. So n here is equal to 1, m is equal to 1, and so our horizontal asymptote is the line y is equal to 1. So this is an x-intercept. So that means your function must intersect that point. So when x approaches infinity, okay, starting from 1, now if you were to look at this, when x is greater than 1, so let's say for example 2, so 2 minus 1 divided by 2 plus 1, this one is equal to 1/3. So what this means is your graph is positive. It is above the horizontal axis. And so as x approaches infinity, our graph approaches the horizontal asymptote. Now, when x approaches negative 1, that is your vertical asymptote. Look at this. Now, when x approaches negative 1 from the right, that is your vertical asymptote. As x approaches negative 1 from the right, so that is a number that is greater than negative 1. It can be negative 0.9, negative 0.999. And so if you were to evaluate this, negative 0.9 minus 1, that's negative. Negative 0.9 plus 1, that is positive. And so what you have here is negative divided by positive. So that means your function is negative. It is below the horizontal axis when x approaches -1 from the right. Okay? So it will approach your vertical asymptote. It goes towards -infinity. Now, you can approach -1 from the left. So starting from -2, you will go to -1. As x approaches -1 from the left, your function will approach +infinity. Okay, look at this. Let's say, for example, -2. -2 minus 1 divided by -2 plus 1. So this one is equal to +3. So your graph is above the horizontal axis. So as x approaches -1 from the right, your function goes to +infinity. Okay? And then as x approaches -infinity, your function approaches the horizontal asymptote y is equal to 1. Let us sketch the graph of this function. So we begin by looking for the x-intercept. So obviously the x-intercept is when x is equal to 0. The vertical asymptotes. So how do you get the vertical asymptotes? So what you do is you equate the denominator to 0 and then solve for x. X squared minus 4 is equal to 0. So these are your vertical asymptotes. And where are they in our rectangular coordinate system? That's -2 and another vertical asymptote. X is equal to 2. What is the horizontal asymptote? The degree of our numerator is equal to 1. The degree of our function in the denominator is 2. So this means our horizontal asymptote is the line y is equal to 0. When x approaches 2, okay, x approaches 2 from the left. So you know what's going to happen when x approaches 2 because that is the vertical asymptote. So it's either your function will go towards a +infinity or -infinity. Okay, so where? What direction? Well, when x is approaching 2 from the left, that means x is less than 2. So if you were to compute this, if you were to compute for this value, okay, x is less than 2, close to 2 but less than 2. So this one is going to be negative and this one is positive. So your graph is below the horizontal axis. So as x approaches 2 from the left, your function goes to -infinity. Okay, so let us now approach 2 from the right. So as x approaches 2 from the right, your function approaches +infinity. As x approaches infinity, this is where the horizontal asymptote will come in. As x approaches infinity, your function approaches the horizontal asymptote, which is the line y is equal to 0. Okay, so this is an x-intercept. So that means your function will cross the x-intercept, will cross or will intersect. Now, as x approaches -2 from the right, -1, -1.5, -1.99. If you were to compute for this one is going to be negative, okay? A negative number that is to the right of -2. This one will be negative and this one is also negative. So x divided by x squared minus 4 will give you a positive value. So your graph is above the horizontal axis. Your function approaches +infinity. And you know that that is the behavior of our function when x approaches the vertical asymptote. Okay, we're almost there. We're almost there. Now, as x approaches negative 2 from the left, if we are to compute for this one, it's going to be negative. Okay? Let's say, for example, this one is negative 3 squared. That's 9. 9 minus 4 is 5. And this one is negative 3. So that is negative. So as x approaches negative 2 from the left, our function goes towards negative infinity. As x approaches negative infinity, this is where your horizontal asymptote will come in. Our function approaches the horizontal asymptote. This one has no x-intercept because the function in the numerator is 8. It's not going to be 0. This function has no vertical asymptote. Why so? Because this one will also never become 0. So this one has no vertical asymptote. But it has a horizontal asymptote. It's the line y is equal to 0. That is that line. And what else? Well, this one, because your numerator is 8, positive, and your denominator is always positive, and this one is negative, so this means your function is always negative, or the value of your function is always negative. It is below the horizontal axis. So as x approaches infinity, your function, as x approaches infinity, your function will approach the horizontal asymptote. But you will begin below the horizontal axis because your function is always negative, okay? As x approaches negative infinity, your function approaches also the horizontal asymptote. Now, your function has no vertical asymptotes. It's defined for all real numbers. So that means we must connect this part of the graph to this graph. And so this is what we do. We will evaluate the function when x is 0. So when x is 0, your function is equal to 8 divided by 4. The negative 8 divided by 4. So that is y is equal to negative 2. So that point, that pair of coordinates correspond to this point. When x is 0, y is equal to negative 2. So we will just connect our graph.